No more peanut pussy, let's get it. Let me lower this volume on music. Okay. Oh, the hair is all fucked up. What in the hell? That's the style, dude. The hell? Alright. Let me turn the fan on. It's hot still. I just cooked. Okay. Trying to figure out my scheduling. I was watching some stuff, getting a little motivated and whatnot, but I had to make sure my schedule made sense. I wake up at 7 for work. And I mean, sure, I get off at like 5, but with commute and stuff, I just say, hey, okay, I'm totally done with work at 6. 100% I'm here. Then, and that includes showering, that includes everything. I'm at home and ready to do something. So I have 5 hours between 6 p.m. and 11 p.m., which is when I go to bed. So, if I say that I have an hour reserved for cooking dinner for tonight, so I cook and I eat, and I cook for tomorrow's lunch during work, lunch here, that leaves me 4 hours, dude, which means 4 hours, there's 20 hours on weekdays, plus, I mean, I should really just lock the fuck in on weekends, really. Like, if I did 6 hours and 6 hours, we've got 32 hours here, plus 55, so you could say it's technically 87 hours dedicated to studying plus working. If I didn't, and these just stayed 3, we're only minus 6, so we've got, 28, or 20, oh, it's actually 26. Really? Yeah, because I'm cutting that in half. Yikers. Okay. So in this case, it's still 81. So, I mean, I guess you could say I'm doing, I don't know, I'm not going to say I do an 81-hour work week, but I mean, I include all the time that I'm there. Because if I was doing literally a 12-hour shift, I mean, that would be 7 plus 12 plus 1 for the mandatory lunchtime that I have to be at work for some fucking reason. And then plus an hour after. I mean, it's 14 total hours for work. Plus 2, that's my waking hours here. And then 8 for sleep. Dude, I'm fucked. Only 2 hours outside of that. And that would be 12 plus 1 plus 1. So that's the 12 plus 1 plus 1. Or no. That would be 12 hours, and then just give it a plus 1. So this is 12 hours shift plus 1 to get home and commute and shit. And really, that's plus another 1 in the morning, but I'm not even going to say that. I'm going to just say I wake up at 7 and I get, no. Because it's I wake up, I work from 8 till 8. That's really what that is. So it's really 13 hours from wake up till end of shift plus hour to 100% be home. Or no, well, it's 13 for the lunch. So it's really 1 hour plus 12 hours of work plus lunch. So wake up to get to work plus lunch plus 1 for like a courtesy to get home with the commute. Bro, that's 15 hours. Plus 1 to cook. Oh, it's over. There's nothing. I mean, if I do the math, I saw that I had 4 hours of time to do my learning stuff after work today, and I only work technically an 8-hour shift. So if I worked 4 more, that's it. I have 0 hours. I'd have to cut into my sleep, and I can't do that. So, god damn, it's annoying, bro. The only way is for me to make up for it on weekends. I'm gonna try and do like a mega mode weekend this weekend, I think. I don't know, I just need to be good enough with my alarm. So the second my alarm goes off, I set it for another hour and a half, and I go at whatever I'm doing. So it's an hour and a half of learning, and whatever. It's an hour and a half of testing. Oh, okay. Another hour and a half of, or an hour and a half of learning, and then maybe an hour and a half of fuck around, and then another hour and a half of learning, another hour and a half of fuck around, another hour and a half of learning, another hour and a half of fucking around, another hour and a half of test, or maybe it's hour and a half of test, and then not finished, and then fuck around, and then another, and then boom. So inefficient, but it's still half my day fucking around. Like, what would that look like this weekend? I mean, I could start, not tomorrow, because I still have to go to bed regularly tomorrow. Weekend, Friday is basically a regular day still. I can't stay up late. So if we do, this is programming related, because I've basically abandoned this channel It's not abandoned. It's just for now I'm not uploading because I'm not doing anything besides programming. I mean, I was doing Unreal Engine stuff here. What was I sorting out? Oh, I was sorting out distance to make the character behave properly so it attacks within distance. And I think there was a bug happening where I would attack and it would take multiple strikes of damage for some reason at once. I don't know why. I don't know if it was a hitbox issue or an overlap or like a collision issue or what. But okay, so for the weekend, if I just wake up at 7 like normal, and then I mean, I don't think I even give myself any time to get my bearings straight. I think I say until 8, this is the bearing straight. So this is shower plus eat plus whatever, etc. Excuse me. And then 9:30, this is learning until 9:30. And then until 11, this is... Or maybe I just do an hour. So we do... or yeah, I guess I do. Let's say I do till 10:30, and this is rest. And then until noon, this is learn. And then until 1, this is rest. And then until 2:30, this is test, maybe, or more learn. It's a lot of information. Yeah, fuck it. Learn more. And then until 3:30, rest. And then until 5, 6, 7:30, 8. Oh, wait, what? Hold on. Till 5. Okay, yeah, till 6, till 7:30, till 8:30, and until 10. So maybe I have 3 learning sessions and then 2 test sessions. So we have a rest and then we have a test 1 and then a rest and then a test 2. And then that's it. Test 1, rest, test 2. And so we have learning 1, 2, 3. So it's 4.5 hours of learning and then 3 hours of testing, which is 7.5. So it's 15 for a weekend. I mean, it's not bad. That's it. That's all I can manage, though. I guess I'll go and I'll just see if I burn out. I don't know. Like, I want to learn as much as fucking possible. I don't want to just do fuck around all day and then do 3 hours of learning. I need to lock it in, but I don't know. I just have to become more disciplined. Okay, no more. Why does that... Okay, sometimes when I put a window on the top of the screen, it, like if I go to the top right, the very, very top right, and I keep going, it gets off of this close button and doesn't work for some reason, but yeah, it's good. Okay. Okay. Oh, and the point here, what were we doing? We were talking about using non-type template parameters as a way of passing const expression values to... I'm not even going to look at the glasses. If they're fine, they're fine. If I see smudge, I clear them. Cool. As a way of passing const expression values to functions, because normally functions are just runtime, so they can't be passed const expression values. But if the function has regular parameters, can it be evaluated at compile time? I don't know. I don't think so. I don't even know how... I don't remember how const expression functions work, really. Do you just do const expression in the return type? I think we glanced at it for a second. Okay, so in this case, we're saying, hey, normally we could pass some double to get square root. And then we do an assert to check this guy at compile time. Or, sorry, at runtime. For if the debug is not defined. So in release, this won't work. And then we're saying, hey, is the double square rootable? Is it not negative? Okay. Or, I mean, you could just say if it's not less than 0. But either way, if not, d is less than 0. And then we return the square root of it. Cool. But the problem is these are compile, well, I mean, you could say compile time literal, whatever. It's a const expression variable, or it's a const expression literal. Well, I guess literals are evaluated, are const expression, because they're known at compile time. Maybe not all though, but I'll say they are. So it's const expression. Well, what if we wanted this to be evaluated using a static assert, like this? Well, then what we could do is, and the point is to pass this to a template. So we use templates to get const expression values into functions and to evaluate them. Seems like, oops. Okay, okay, what the fuck happened? Okay, we need C assert. We need, I think that's it, maybe. So we'll do type, we don't even need a type name. We'll just say int x, right? Is that how that's gonna work? We'll do thing, and then we'll just say no parameters, and then it just does something with x. Sure, I think that's okay. This is a non-type template parameter to pass const expression value to this function. Okay, and then we can assert, static assert, that x is greater than 30. X. Well, we don't even need that. It's fine. Cool. If we did this, and then just did that, hold on, what's happening here? Int x. Oh, it's not const. Well, what if we said constant x? Uh-oh. Still not evaluatable at compile time. Because when we call this guy at runtime, then the value is known. And it isn't. What if we gave it a default value? Still. Even still. But if we remove this guy and then we add template and x, and then we're cool. Compile time assertion check for x. Cool. And then I could call do thing. Cool. Oh, and actually it would want do thing 50. Boom. And it works, doesn't do anything, but cool. Okay. So that's how we can get compile time values to it and evaluate it at compile time. Otherwise, we can't use static assert in this function. All right, is that how that works? Or we can't do a static assert based on a parameter. We could define, well, could we even define something in there? I guess we could, right? Because if it's a const expression variable that we create, it's checking it at compile time, and I guess it's checking just that. So yeah, we can't use a static assert on things that aren't known at compile time. So it'd be better if we could do a static assert so it's caught at compile time. Yeah. Oh, and the error. Oh, well, you're saying the error here is this guy getting compiled out. So if we use this in release mode and this assert gets compiled out, then it's going to say, hold on. So if you're doing that, it's only going to, it'll return 0. Oh, so if the point is that we want to make sure to abort if the value is negative, and we 100% want it to abort, then if we do it at runtime, it's not going to abort. This gets compiled out, so it's either just going to return 0 or it'll do it properly. But if we want it to abort and we want this assert to be used, then we need it to be a static assert. Well, yeah, because the static assert is ran at compile time. So even if it, I guess static asserts aren't compiled out. They're just compiled and evaluated at compile time. We do what we want if it's a non-type template parameter. Yep. And so we say, hey, this is double D. We're passing it to get square root as a non-type template parameter. And then we can do a condition, a const expression condition to evaluate it. If we don't do const expression, then we get a warning as an error. Not sure why we're ignoring the const expression part here. We've already done const expression conditions. Until C++ 26. What the fuck? We can do that. This fails to compile. Why? Or hold on. So there's here, but then there's here. So if we said, hey, just continue the template, and then we put in an actual number, and then we do a static assert, check if when it finds this, and we're using D, wait, hold on. Are we saying this one fails to compile? Oh, it is this one. Okay. Then why are we saying we can do exactly what we want if we do it? And then give me an example where it doesn't work. What? Must be non-negative? Oh, well, yeah, it fails to compile on purpose because it's non-negative. Cool. When it encounters it. Okay, yeah, so this is on purpose. So basically what it's seeing is, oh, we're learning how the non-template parameter, I was going speaking a little Mexican right there, man. We're learning how the, it's a cool accent. If we do a non-type template parameter, and that guy's double, then if we're calling it with that syntax, it seems like it adds this guy here with this literal value. Instead of it being the type, it's just the value. So it'll do double, -5 get square root, static assert, -5, oh, and then right here, boom. Yep. It is not, it is greater than or equal to 0. It is not, therefore, boom, it stops. And it, yeah. And in that case, even if this wasn't here, then we would just be returning 0. They're used primarily when we need to pass const expression values to functions or class types to be used in const expression or in contexts or in const expression contexts. Bitset uses non-type because the number of bits must be const expression, so we can't change the number of bits, seems like. Yeah, we definitely can't. Oh, okay. Implicit conversions for non-type template arguments, meaning we have an int, and then what happens if we pass like a float? If we do, well, if we do a float, then we get a narrowing conversion. But we say template, say double D, sure. Would do thing, and then nothing, and then it just says static assert. Oops. Oh wait. Static assert is already a thing. It's not needed. We'll just say 3 is greater than 0. Okay, cool. All right. So static assert already exists. Regular assert does need CAssert though. So we can static assert D is greater than 0. Sure. But then I can call do thing 3. Oops, hold on. Oh, hold on. Oh, is it cool? Let's use a template. It takes a double D. Let's avoid do thing. I mean, it doesn't match, but it seems like it's erroring, but promoting. Or numerically converting, because we're going from integral value to floating type. And then if we just test. Uh-oh, here we go. It was fine until we did the rest of this stuff. Oh, well, isn't it if const expression so that we're cool? Otherwise, it gives us a warning. Yeah, so this works. It just doesn't. The IDE isn't happy because of the promotion or the numeric conversion. Oh, so like a character's weight. In this case, C, so like 68. Oh, well, 68, but plus whatever it is. Oh, no, it'd be 97 plus 2. Yeah, that's why. Okay. Yeah, so we're saying we're calling this print instantiation, or I'm just going to say specialization. In this case, it seems like it's explicit because it's already there that we wrote ourselves. And we call it with a non-type template parameter of 5, which then it seems like is assigned to n, which we can then use as a variable or an object within print. But we could also do a character, which would be promoted from its 1-bit version to its 4-bit, or I'm sorry, its 1-byte version to its 4-byte version, and then boom. I'm gonna try and get some music going. Oh dang, different. Is this any good? Hell no. Oh yeah. Okay. Looks good, sounds good. Which then prints the values an int. Yeah, we're just doing a little character int conversion. Coolio. Only certain types of const expression conversions are allowed. Meaning, in data type conversions to a non-type template parameter. So there are promotions, that's this case. Integral conversions, character to long, or okay, so just numeric conversions, but for integrals. Seems like to floats too. User-defined conversions. So if we have some sort of class that can convert to something, we can apparently do that. We pass it the class, and it's expecting an int, and then it converts it to an int because there's a user-defined conversion. Cool. And then L value to R value, I don't know what the fuck that means yet. Some variable x to the value of x. What in the fuck? A variable x to the value of x? I don't know what that means. Less permissive than regular. Well, yeah, there's a lot of less shit here. A lot less shit. Oh, so we can initialize a variable of a double with a const expression int, and that conversion will drop the const part, and it will numerically convert the int to a double. But a const expression int, but for a non-type template, it will not drop the const and convert it. Let's see what happens there. Yeah, sure. Excuse me. Buddy, are you sure? Seems like it's working. Seems like the IDE is allowing it though, maybe? Maybe this is some implementation specific shit? Long story short, non-type template conversions require are more restrictive than regular implicit conversions. Implicit non-type template conversions are. Okay. Converted constant expression. Oh, okay. CPP reference. Okay. Gotcha. Meaning that ambiguous matches are more likely because it doesn't have all these rules to say, oh, hey, this is hierarchy over this, over this, over this, over this. Therefore, if you do this call, this call, this call, this call, this prioritizes that, prioritizes it. Instead, we might just get, oh, it's ambiguous. Function template calls. Hold on. Function template calls to function definition or template definitions. Oh, so if we are going to do the character version or the int version, these are explicit specializations for non-type template parameters. And we pass it a number. Well, is it being numerically converted down to a character or staying an int? Or is it being promoted to an integer or staying a character? Really, and both are ambiguous. So there's no, oh, promotion is favored over, or explicit match is favored over. It's actually, wait, really? Even an implicit conversion, even though we have an exact match already? Wow. Really? I wouldn't expect that. So if we did index, would do thing, sure, and then it doesn't do shit, or let's just say it uses X, okay, and then we have template character Y, sure, and we did void do thing, oops. And then it does something with Y. And then we call do thing 3. And then do thing C. Oops, what the fuck? Really? 2 ambiguous calls. Template float F. void do thing. F. Even that! So it seems like if conversion is possible, it's going to do it at all. So there's no difference now between, or if it is in the same realm, then it's the same. So it seems like you can't have non-type template parameter overloads that only differ in that if the non-type template parameters are anywhere even in the same world. Wow. What if we did a Boolean though? Holy shit, is that still the case? Truncation from int to bool? It's actually ambiguous. This is ambiguous and holy shit. And the other one had more errors because we have a narrowing conversion. We're going from an int to a bool, so we're going from very like, well, in this case, yeah, number 3 down to a bool, we do get a narrowing conversion because bools can only hold 0 and 1, not 3, nor 2. Wow. Okay. Using auto, really? So we could do that. We could say I don't like this guy. Who gives a fuck? Alright, let's do sure. Really? What if we did oh wait, hold on, but it does have to be const expression. But if it's literal, uh-oh. What? A non-external. Doesn't it mean an internal entity? So auto doesn't like that. What if we did some standard string action, huh? Can we have it? Yeah. We can't do a const expression string literal. Damn. Okay. Oh, well, I'm fucking opening up Darkest Dungeon. Can we not? Okay. Alright. So we can do auto for some regular shit. So it handles, okay, it does 5, and oh, it handles C, and then oh, it does some shit to it. But then it's not checking for semantics either. So hey, well, we're fucking adding stuff to C. Maybe we want to do that. Maybe we want to count out the alphabet. Or maybe not. Okay, and we're outputting it. Well, it's saying, hey, output a character, output an integer. And we're saying, why is it not an ambiguous match? Well, 1, there's one fucking template, but 2, if we call it and it says, hey, there's a 5 and it generates, and then another, oh, the point is it looks for an ambiguous match first. So it looks to see if it already exists. And then goes, really? So it... Oh, so the point is if there aren't ambiguous, or if there are ambiguous matches, the template says, hold up. But if there aren't ambiguous matches, then the template says, good, go ahead, and then do the specializations, and then we can call those specializations then. I guess not. We're not, it doesn't make specializations and then we call them. We simply have one primary template, and it generates the right specializations with the calls, and then we're good. As long as the specializations aren't ambiguous, already written in the source code. Gotcha. Yeah, exactly. There's only one template, so there can't be. Makes sense? Yeah, if we had just done this, then it's actually cool. because, oh, hold on. So this is for extra shit. This is, I guess it'll check for the literal value instead of it just looking for an int. It'll actually look for, yeah, that is weird. I don't know why I would do that. Hence, that's probably why it's advanced. But yeah, I guess I wouldn't do that because I'm not going to know what the fucking values are. I'm not going to say, hey, do this template if you get this value, do this template if you get that value. And especially if I already put it in, we probably get we might get an ambiguous match then. Okay. Const expression function template with a non-type template parameter. Okay, let me do some push-ups real quick and then I'll be good to go. Yeah. Or should I do it? Maybe. I don't give a fuck. I'll just leave it. No, we can go. Alright, left first. Okay. It's 2. My back cracked. Oh. Oh. Okay. Excuse me. All right. What are we wanting to do? A factorial function. Oh. We can only factor. Yeah, I guess you can't factorial negative numbers unless you had it so that it added 1 and then multiplied it by itself. But then you'd be getting alternating negative and positive numbers, right? Because you'd have -5 times -4 positive now times -3 negative now, etc. So depending on if it's odd or even depends on if it's negative or positive, which would be funky. So I guess no negative factorial. Okay, cool. So we'll do a template. We'll just say, okay, int factorial target, sure. And then void, what are we doing? Are we returning the factorial? Yeah. Sure. Okay, so we'll probably just return an int. Sure. Yeah, that's what I'll do. And then do a temporary variable. We could just do int factorial. Sure. Factorial sum? Yeah, because it's this. No. Factorial product. Sure, we'll start at 0. And so we could do a loop while the factorial is greater than 0. So we could just say while factorial target is greater than 0. We stop once it's 0. What are we doing? We will say that, I mean, I could just initialize it here. I guess I could do that, and then we could just say that factorial target is now itself times this is factorial product is itself times factorial target. And then we could just say minus minus factorial target. So that's what we want to do. This feels kind of messy. I mean, I could just initialize it to be 1. What if we did that? So if we say there's some sort of sum guy and it starts at 1 and it's initialized, and then we're assigning it to be, oh, I mean, maybe I just do that because we're updating factorial target anyway. So we could just say factorial product is factorial target times, and I could decrement it here, but I'd rather do it separately. I guess we could hold the initial value though. And so we could just say, okay, decrement factorial target. But if it's 1, so we only care when it's greater than 1. Okay. And if we've already decremented it, then it's times equals factorial target, right? And so if it's greater than 1, that means it's 2. And then this is, if it's 2, or if we decrement it to be 2, then it's itself times 2. And then if that is something else, maybe this works. All right, so let's say factorial target is 4. So we want it to be 4 times 3 times 2. That's 4 times 3, that's, right? That's 12 times 2, which is 24. Isn't that the final value? Okay. All right, so we initialize factorial product with 4. Okay. And then we decrement 4 to be 3. And then we say, hey, this is 4 times 3. Okay. So now it's 12. And then factorial target is 3. Or, so it was 4. Now it's 3. So we subtract it. Now it's 2. Isn't that all that's happening? So it's 4 times 3 times 2. That's it. So at first it's 4. We say, okay, 4 times 3, 12. Oh, times whatever it is, times 2, 24. Okay. Times 1. Okay. So, I mean, we could say, well, it's greater than 2 almost. Because if it's greater than 1, if it's greater than 2, or if we say if it's greater than 1 and the value is 2, we subtract it times 1, and then, yeah. But if we do times 2, then 1, at the end, we just return factorial product. So if it's 3 at first, we have it's initialized to be 3, which is greater than 2. So we subtract 1, so now it's 2. And then factorial product is 3, which it already is, times 2. So it's itself times 2. Oh, it's not greater than 2. That's it. It's 6, which is 3 times 2. Okay, cool. And then if we did greater than 1, then it would be 2, but then we would subtract 1 from it, and then it would just be itself times 1. Yeah, that's fine, I think. And so in this case, hold on. A const expression function template? Hold the fuck on. Because we have to return something that's const expression then, huh? I don't know if this will work. So what are we doing? 0? What? Well, it's not. Yeah. Okay, well, we're cooked now. And we're saying factorial of 0. Oh, and that needs to be 1? Oh, so I guess we could just say... So what if we say, if I just started off at 1... Just do this. Or wait, yeah. We could just start it off at, or no, because we have to start it off as factorial target. Or no, we can start it off as 1, and then just update it to be factorial product is factorial target. So, factoriable, already factored. Or, well, factorial. I don't know, factorial? Yeah, I guess. Return 1 if... Hold on. Sure, I guess we say if it's greater than 1. So if it's already 1, we do this. But if it's greater than 1, so if it's 2, then we say, okay, you're 2 now. And then you're 2, but now this is 1, and then you're 2 times 1. Okay. What if we say const expression int, like that? While const expression, is that a thing? I don't know about that. L value? Do I have to fucking save it? Maybe I have to. Sure. And then what if you say x, x, x? While this factorial target? Oh, what if we say this? Oh wait, it already is. Okay, that's not the issue. How do I make this okay? Conditional expression is constant. Well, the factorial target is whatever the number is. So, oh, this should be x. X isn't constant. I was just missing one thing. Okay, and then we can static assert. I don't like doing static asserts and figuring and having the result right away. Oh, great, it failed. Okay. Oh, good. Let's just do piece by piece. No, let's put it all in. Fine, sure. Oh, so we could do a static assert. And it failed because of this guy. If I remove that, then it's not that. Well, hold on. Oh, well, we could just say is greater than, or I guess we could say greater than or equal to 0. So it's not returning 6 here. What's the issue? Okay, so we're saving 3. So this guy is 3. If it's greater than 3. Oh, the problem is each loop I'm setting this. Well, fucking duh. Okay. Oh, shouldn't I just do that in the beginning? I don't like where I get on an idea and then I have to just fail it. But yeah, I guess that's just the way of the world. That's how it is. Alright, so first we're going to assert that we're not doing a negative value. So this guy is cool here. And I could do a static. Well, it doesn't matter. Because this is the one that would fail. Okay. And so we can have factorial target. I could do an if. To catch that early on. Or I could just have int factorial is, and I assign it to be to 1. Return factorial. What are you complaining about? I don't know why you were. I really don't. If I type anything, what are you complaining about? Oh, well, yeah, it's supposed to fail to compile. Okay. Well, why was it? Why is it not failing to compile? If we do factorial -3, this guy should be seeing -3. It's not greater than or equal to 0, so it should just be failing right here. I'm not sure. Excuse me. So we could just start the factorial to be 1 by default. Because any number that's factoriable should be 1, or it should just fail. And so what should we do? We could just say I mean, I guess a for loop could be cool too. But I kind of want to try while. You could say while. What if we just tried decrement factorial of target and then did that again? Wait, how did I control? I think I can just control C. Yeah, align instantly. Yeah, it needs an L value. So it seems like it needs, I think R's are literals. So I think we need to store this. Okay, so I might just have an int current, or we'll just say factorial product. I like that. And then we could just say remaining factorial. And we just initialize it to be factorial target. Okay. I'm getting a million errors, holy shit. Oh, oops. Yeah, we're not using it, but that's fine. And then those are failing, and then 5 is that. Yeah, it's fine. Okay, cool. It's just these guys are failing. All right, cool. So we can do this. And then we could say if, or sorry, while remaining factorial is greater than 1. If it's greater than 1, I don't want to subtract it and multiply 0, so do we say greater than 2? Oh, we could say greater than or equal to 2. So once it's less than 2, we don't proceed. But if it is 2, then we can subtract. But shouldn't it just be negative or greater than or equal to 2? No, I guess we do greater than or equal to 2. That way, if it is 2, then we return what it is, which forces us to multiply it by -1, but it's okay. And I don't want to just have a condition, so if it's 2, return 2. Like, whatever, dude. I'm having one loop that handles all the shit. So, we have remaining factorial is greater than or equal to 2. We say factorial product is... Do I decrement it in here? I kind of want to. I mean, I could have a temporary little variable. We could say decremented factorial is I mean, we could say so many fucking variables though. I want this guy to be the remaining or the remaining factorial times 1 less than it. And then do I just decrement it after? I guess I do. Yeah, sure. Sure. And then decrement. And so remaining factorial is that times that. So if it is greater than or equal to, so if it's 2, then it is equal to 2. Oh, but it's not adding it to itself. So it should be, or hold on. It should be, hold on. So I could say, do I do an if? No, I can't do an if static assert. I can do the static assert though. And then it should be itself times it. I mean, I guess we could say if factorial target is greater than or equal to 0. Or I guess we could say, okay, factorial target is 1, but if it's greater than or equal to 2, then factorial product is factorial target. And then we could say time is times equals. Line 4, is it saying it? Conditional expression is constant for 7. Oh, hold on. Is it going to show me? Line 29. Yeah, why do I have to fucking look in here? Why doesn't it just flag right there? Okay, I mean, it works. Is this a terrible, terrible way of doing it? It's 20 lines of code for this one fucking factorial shit. So, handle negative non-type template arguments. Okay. Now we were cool. Hold on, we were just cool. Now we're good. Bro. Oh, so it's after I compile something. Or when I have to click the line, I guess? When I type in the line and then click in it? I'm not really sure. Alright, so we have a static assert to handle the negative non-type template arguments. Okie doker. And then we have factorial product. Factorial to return. Or we could just say we could say if it's greater, so this is a static assert. So if it's greater than or equal to 0. Oh, but this is fine if it's 0. Yeah, sure, I guess so. I guess we do that and then we just return it in the end. So we say, hey, there's a factorial product. This is the final value we're returning. Keeps track of factorial. All right, well, it's factorial result. And then we need L value to store the non-type template argument, because otherwise we can't store it and access it in memory, seems like. If it's greater than or equal to 2. So it has to be 2. Or we could just say if it's greater than 1, right? No. Because if it's 1, we already don't want to do shit. We just want to return it as is. If, because then we'd be assigning it itself, it's already 1. Why the factorial of 0 is 1? 0 times, yeah, I don't know. Extra lines here. Why? Okay, and then we're saying only update factorial sum if we have a number or have a large enough number. Okay. And then factorial loop. And so it's multiplying it by itself times 1 less than the factorial. And then we subtract factorial. So if it's 4, then we already assigned the guy to be 4. And then we subtract times 3. And then update this guy to now be 3. And then it's 4 times... Sorry, hold on. So if it's 4 times 4 minus 1, so 3. But now it's actually 3. And now it's 12. The result times 3 minus 1, which is 2, and then it's 2, and then it's times minus 1, cool. And it stops so that once it's, yeah, if it's 2, it's multiplying it by itself. If it's greater than or equal to 2, then it's already 2 here. And if it's 2, well, 2 times 1. So we could just update it to be greater than 2. Because otherwise we're just doing an extra loop every time something can be factorial down to 2. Cool. Alright, it's only just failing there. Works for me, I think. What's a better way of doing this? Like, I need to return the thing. I can't just do it. I can't assign factorial target to something to store the value, but then multiply it by itself. I need another variable to store the next stuff. So I have some sort of product. So if it's 80 that we're passing, okay? 80 times 80 minus 1, 79. So 80 times 79 is this times itself minus 1. Well, if it's storing the big value, it's not storing 79 to decrement anymore. So we need, I wish that factorial target just stayed, but I guess this is just a literal. It's a const expression literal value that we can't access more than once, seems like. Or we can't update. Yeah, duh, it's const expression. We can't update it. So this is an L value, which seems like it means it's a non-const variable, I think. Or that it's just a variable. Yeah, I guess so. We're only updating the factorial sum if we have a large enough number. So, I mean, we could say update it and then return early. But then isn't that even more complex? Like if I just say if remaining factorial, or sorry, if I say if factorial target is less than 2, return 1. And then that would be the if and the return. And then we would just say update it here because we would have already returned otherwise. But instead, this way handles both cases without having to add anything extra. There's no extra conditional to handle something else. So in this case, is this simple? Does this make sense? And am I repeating myself? Handle negative ones. Okay, so we want to fail compilation if it's a negative non-type template argument. Okay, because we can't do a negative factorial. Okay. Have some sort of variable that we store the result in and initialize it to be 1 at first. I mean, we could do an else, do 1, but we also need to store the value permanently so that we can update it. So we have 2 variables. I think both of those are needed. We only want to update factorial products to be bigger if the value is big enough. So I could either say, hey, is it small enough? Return that, and then update it. Or I could just say, leave it as is, and then boom. And then while the remaining factorial is greater than 2, because if it's 2, we're multiplying it by 2 minus 1, which is no change. So it needs to be greater than 2. We're multiplying it by itself times, we're setting it equal to itself times 1 less than the factorial. But I need to decrement the factorial each loop here and do the minus 1. Because if I decrement it and only decrement it, then if I decrement it early and then multiply it by it, then I can't tell how big the factorial is, or how much the remaining factorial is. If the remaining factorial is 2, and then I decrement it to be 1, and then I multiply it by 1, then what am I? Well, if it's greater than 2, let's say it's 3, and then I decrement it to be 2, now we have whatever value. Let's say it's 3 times 2. The problem is that how much I have to step back by 1 each time I'm doing this. So that once we've said, hey, there are 3 numbers here. This times itself minus 1. But then I have to subtract 1 so that we know what the next number is. So instead of subtracting 1 from it, and then multiplying it by that, and then subtracting 1. So could I just subtract 1 from remaining factorial? If I say, if I do that, how do I uncomment it? The fuck is TypeScript? Oh! Toggle line comment, toggle block comment. Control K, control that. Or control shift backslash. Like that. Oh shit! Never mind. So if we did this. Oh shit! Uh-oh. That's not good. So if we did that, Uh-oh. Oh, it doesn't want to undo. If I do that, we can undo. If I do that, we can undo. Is it when it's... We do this. Uh-oh. Is it when it's too large? Is it when it's outside the loop? So the loop is cool. But is it when we get something else? No? Is it when we get too complex too complex statements? I don't know. So if I just said instead, I think I can do this. And then we just say decrement remaining factorial. And then we say factorial product is itself times remaining factorial. Oh, it seems like this is working, right? So if we say, let's say we have six, let's say we have 5, okay? So we say, all right, remaining factorial product is 1 at first, and then we save 5, and then we say, oh, remaining factorial is actually big enough, so we're going to update factorial product to first be that. Because otherwise, if I start it by saying factorial product is itself here, I mean, I could have like a is first iteration or something, but fuck it. Either I can have a thing in here that checks every time, or something here one time. I'll do that one time. Less code, I think. And then, so we have 5, and then we decrement the factorial target, or what we have stored from the factorial target, so the remaining factorial to be 4, and then now we have 5 times 4, okay, and then I decrement it to be 3, and then it's 20 times 3, we have 60, but then it's 60 times 2, 120. I don't know why I was doing it this other way. Cool. What do you have? You motherfucker, how does he do it in 2 lines? I cannot. He has a static assert. And he's a better type template name, because I was doing some cap shit. N is better. Fuck. Yeah, it's just better. I mean, I think mine's more idiomatic, but it's just fucking more reading, dude. So he has return product. Int product he first does to be 1, and then he just does 4. Oh, well, the increment and shit is already built in. So for him, what is he doing? Oh yeah, so he has a product. Oh, and then he has an I that's counting. So you can actually do it different ways. You can say with a while loop that doesn't already have another variable, I don't need to make anything else. I is the shit that I'm multiplying by. So instead of it saying, hey, we're doing 5 times 4 times 3 times 2 times 1, we're just doing 5 times 1 times 2 times 3 times 4. So while it's less than the target. So we could instead here just say, okay, we have a static assert that the shit isn't negative. So n is greater than or equal to 0. It's not negative. Excuse me. Handle negative value, or non-negative, non-type template argument. And then we could just have sure an int factorial product value initialize, or we could start it to be 1 and then return factorial product. Oops. And then we could just do for I is, or I, we start to be 1. And while I is less than n, because we don't want to include n times itself, and then we can just increment I, and then we just say factorial product times is itself times I think. Uh-oh. Oh no. Is it cooked? Oh, well, I didn't say what type of variable it is. Uh-oh. Okay, these failed. These are not it. It is not correct at all. So we say it's 1. Hold on. 1 times 1, and then... Uh-oh, hold on. Wait. Wait, wouldn't this work? Hold on. So at first it works. But then we say for I to be 1 while it's less than the number we're passing in. We're saying factorial product is 1 times, or so it's itself times I, so it's 1 times 1. Okay. And then we increment it to be 2 times 2. Okay. Times it. Oh. So don't we go through n? Nice. That makes sense. Because I was missing the last bit. I was going to say this logic seemed like it made sense. I mean, we could make this super minimalistic, but that's just stupid. I'd rather handle that, and then we say... So we handle that. Factorial result to return. Factorial loop through factorial products until done. Sure. Something like that. Until through factorial number. Cool. N. Cool. Seems okay. Yeah, same shit, 5 lines. So we're first handling this case, and then we're saying, hey, we have some sort of product. I like factorial. I mean, I guess you assume that this is the product of factorial, but I like being specific so that if this is like attack shit, and then I just have damage, whose damage, motherfucker? I like saying that this is a factor, or a factorial product. That way you look at here, and you say, oh, even if you don't know what this factorial, or what this function is even called anymore, you still know what the variable is. So we have factorial product, and then we're saying, hey, oh, well, I guess we only care about 2. I mean, that makes sense that we wouldn't want to multiply it times itself. We would start with 2. And that's only if I is greater than it and it's 1, we're just going to leave it be. If it's 2, I think leaving things as 1 makes it easier to understand because it loops through every possibility. Because technically, in the factorial formula, it's 5 times 4 times 3 times 2 times 1. It's not 5 times 4 times 3 times 2. Stop. It's not, oh, hey, here's a counter and we set it to this, multiply by this, subtract 1, multiply by this, subtract 1, subtract, do it again. And each time we subtract 1, is it 2 or greater? Yes, continue. Oh, is it 2 or greater? Subtract 1. Is it 2 or greater? Subtract 1. Is it 2 or greater? Multiply and subtract 1, etc. Right? Okay, I'll take it. I did it. I just didn't do it in the easiest way. Well, I forgot that I was going to do it in a for loop as well. I was doing it as a while just for hard mode, but then it requires you to make your own I as a permanent variable, not just one that's within there. Because here, this is a variable that it almost feels like a static local variable because it persists through shit. This guy lives after each loop. And for me to have a variable that lives through each loop in a while loop, I need him to exist outside the while loop. What even happens if I just have while true and then in X? And X is 3. Oh, okay, so we can just do that and then oh, I didn't call it. I'm totally not using the number, but okay. It is an infinite loop. Really? So it actually creates a new one, huh? Oh! Alright, well, that's the learning for today. Next will be the test in a little. Or, well, actually, right now.